Hi everyone, today we're doing 7.4 division property of exponents, and basically you're going to follow similar rules like you did with the multiplication, just instead of adding the numbers together, you're going to subtract the numbers. Now let's look at why this works. If you notice this problem down here, you have 4 to the 5th divided by 4 to the 3rd. If you were to write this out in expanded form, you have 4 times 4 times 4 times 4 times 4 over 4 times 4 times 4. So if you cancel out what they have in common, you're only left with 2 4s on the top of the fraction, which means it's 4 squared over 1, or 4 squared. So if you were to just subtract those exponents, 5 minus 3, you would again get 4 squared. So let's look at this one, for example. X to the 8 minus over x to the 3rd, it would be the same thing. We're going to subtract the exponents, and you get x to the 5th. If you notice this one, you're going to end up with a negative here because 2 minus 5 is negative 3. And then with the ends, you get 1. And since you have a negative, don't forget you have to move that down. So your answer is n over m cubed. Okay? And then the last one, the x to the 4th would become a 0. And we know anything to the 0 power is 1, so we can cancel those out. Here, what you could do is you could move them around first so you don't have negatives. So you'll have y to the 5th, z to the 8th, over y to the 1st, z. And then you can subtract, and your numbers will be positive. It's a little less confusing. But it's up to you. If you feel comfortable doing -1 minus -5, that's fine also. So here are some examples for you to try. Go ahead and take a few minutes. Pause the video. Don't forget your properties, because now you're going to be using all the things that we've learned. So multiplication properties like power to a power, distributing the exponent, and also division property. So go ahead and check your answers. Notice how on number 11, we left 12 to the 4th and 15 to the 4th because those numbers are very large. We don't have to evaluate that. However, you can't reduce anything because you haven't evaluated. So since the numbers have exponents, you can't actually reduce anything on those numbers. But the p's you could combine. And then the last one, I went ahead and put the -3 exponent on every number, but you can also flip the entire fraction first and then make the 3 positive and put that exponent on every number if you want to avoid the negatives. But that's totally up to you. I did it the other way so you could see all the steps, and you'll notice that at the end I did evaluate those numbers because those numbers are smaller. So in the last example we have scientific notation with division. And with scientific notation, you're still going to follow the same steps, kind of like with the multiplication, where you're going to divide the numbers and then subtract the exponents on the tens. So if you look at the problem, it says population density describes the number of people per unit area. During 1 year, the population of Angola was 1.21 times 10 to the 7 people. The area of Angola is 4.81 times 10 to the 5th miles squared. What was the population density of Angola that year? So what we're going to do is we're going to take that population and we're going to divide it by the area to find out what it is per square mile. So we can find the population density. So if we do the division of 1.21 divided by 4.81, we get approximately 0.25, and then you do the subtraction on the exponent, so times 10 to the 2nd. But that's not in scientific notation because there's not one number in front of the decimal. So I'm going to move this over, and since I'm going from smaller to larger, I'm going to subtract 1 from my exponent. So now I have 2.5 times 10 to the 1st. And that is my answer for the population density of Angola that year.